All right, Precalc, we are moving on to finding domains and asymptotes of rational functions. This gets a little shady again. Our essential question is, can you find the domain and asymptotes of rational functions? We are on lesson 2.6, rational functions and asymptotes. Remember, this is kind of saying the function has a numerator over a denominator, but remember the denominator can't be 0. Never, ever, ever can it be 0. So the first question says, find the domain of f of x equals 1 over x and discuss the behavior of f near any excluded x values. Well, from what we know from parent functions, a graph of 1 over x is going to, I'll graph it in a different color, is going to look like this. And we've discussed a little bit about vertical asymptotes, but in this case, it is going to have a vertical asymptote at x equals 0, which is right smack dab down our y-axis. So it says discuss the behavior. So notice what's happening if I'm going, well, first of all, let's answer the first question. The domain. The domain is all real numbers, but x cannot equal 0, because remember that vertical asymptote is where x cannot equal. And then it says discuss the behavior. So notice as it's going down this way, it is going, the y's are going to reach negative infinity. So they're going to get really, really, really close. -1, -2, -3, -99, -100, but they're never, ever, ever going to touch this y-axis right here. Okay, same with if I'm looking at it this way. Notice the x's at 0, well, not 0, but at 0.1, 0.2, 0.3, those are going to be really, really high, reaching positive infinity. And we're going to be working a lot with negative and positive infinities. All right, so these notes get very, very confusing, but we have some rules that we do need to know. Notice this is numerator over denominator, and we're really going to focus on this x to the nth and the x to the mth. There are two things that are happening, one that we really have to really focus on. So it says the graph of f has vertical asymptotes at the zeros of the denominator, which makes sense, because remember, if this is equal to 0, that's where it would be undefined. So if I made all of the denominator equal to 0, that is going to be where we have vertical asymptotes. Now, something new for us that we're never, ever, ever going to forget, because we have to know this for calculus, is these rules for horizontal asymptotes. So there are 3 different rules. The first thing is talking about n is less than m. Now notice we're talking about these right here, the exponents. When it's in descending order, the n is less than m. If that is the case, then the graph of f has the line y equals 0 as a horizontal asymptote. And as you notice, that's right on the x-axis. Let's look at the next rule. If n is equal to m. So if those numbers are equal, 5x over 7x, it says that we are going to take y equals the coefficient. So I'm going to write that out for you so you could see. If I literally had f of x equals 5x over 7x, remember we're talking about where our horizontal asymptotes will be. In this case, it has to be the coefficients. So y would equal 5 over 7. So that's where we would put our horizontal asymptotes. Still working on those horizontal asymptotes. If n is greater than m, then it has no horizontal asymptotes. So let's look at a few graphs. Well, let's look at a couple right now. Find the horizontal and the vertical asymptotes of f of x equals 5x squared over x squared minus 1. Well, I know the vertical asymptotes are going to be when the denominator is equal to 0. Well, we can factor that. That's going to be x plus 1, x minus 1. And if I was to make these equal to 0 and solve, remember x here would equal negative 1 and x here would equal positive 1. So my vertical asymptotes will be at x equals negative 1 and x equals positive 1. For the horizontal asymptotes, we have to go back up to the rules. So I know that they're equal. I'm going to circle that right now because this is an x squared and this is an x squared. And it tells us in the rules if they're equal, notice that's the one in pink, if they are equal, then we are going to take those coefficients. Well, what is the coefficient of the numerator? Good, the coefficient is 5. What is the coefficient of the denominator? 1. So we know that horizontal asymptotes will be at y equals 5. Now, they didn't tell us to graph this, but let's just kind of take a look at what's happening here. I have two vertical asymptotes, one at negative 1 and one at positive 1. And then I have a horizontal asymptote at y equals 5. So something's got to be happening in this graph. I'm actually going to graph it for you so you can see what's happening. I'm going to graph it in pink. So this graph has two, what we almost would say would be rational looking parent functions here. And then not quite going past 0, kind of a upside down parabola there. So notice just by plugging in numbers, if I had to do this all on my own and I didn't have a calculator, I can plug in numbers like 0, negative 1/2, positive 1/2, and then moving over past 1 at 2, negative 2, 3, negative 3. And you could almost figure out what's happening here without a calculator.